Let's solve an equilibrium problem that has one unknown. And when I say it's got one unknown, okay, I'm saying that there's one force here that's going to put these two other forces in equilibrium. That is, when you add all these three forces up, okay, it's going to add up to 0. And the way we do that is we have to look at it in the x direction and the y direction separately, right? So let's look at the x direction here, okay? In the x direction, I've got this component of that guy, right? Now notice that's 29 degrees, the hypotenuse is 23, right? So this side here is the adjacent side, so this side's going to be 23 cos 29, and it's cos because it's the adjacent side, right? All right, and then this side here is going to be 23 sine 29, and those are the components. So when it says express the components or calculate them, that's what they are. There they are, okay? And then we can look at the components of this guy. And this guy is, that's the adjacent side there, right? And so this is that side there. And this is, by the way, the y component is 14 cos 34. And then the x component here is going to be 14 sine 34. Because it's opposite, right? Okay. Notice that what cos is giving us the x component here, and cos is giving us the y component there, and that's because these angles are, one of them's pinned to the y-axis, one's pinned to the x-axis, but that's not really a problem. Okay, so now we have to do math. So I have to do math, and I have to do it in blue. You know, I can't do it in red. Okay. So in the x direction, we've got these forces. We've got this guy. Notice it's positive because it's to the right. We've got this guy. This guy's going to be negative, okay, because it's to the left. And then, of course, we've got a component of this guy here, right? So let's draw these components here. Okay, so this is, we'll call this Fx, we'll call this Fy. And these are just components of this force. And ultimately, we could find some angle, like this angle or this angle or something. Okay. All right. So let's set up our x equation. Let's find all the x directions. So here's an x direction. So I'm going to go Fx. Now, even though we know it might be to the left, just because of the way these things look, just make it positive. The unknowns, always make them positive. So Fx, and then I'm going to say minus 14 sine 34. Right, and I'm making that component negative because it's this arrow goes to the left. It doesn't go to the right. And then I'm going to say plus 23 cos 29. And then all of those add to 0. So these are our x directions, right? This guy, this guy, this guy. And then we're going to have 3 y's. The first one is, of course, the y component right here. And then we've got this guy here. Right, so plus 14 cos 34. Okay, then we got this guy right here. So plus 23 sine 29 is 0. So all the y components add to 0, all the x components add to 0. The force adds to 0 in the x and the y, right? So now we just have to do maths. Okay, are we ready for this? First thing I'm going to do is I'm going to check my mode. I am in degrees. Okay, this is good. Okay, and so now let me calculate. Basically, Fx is just going to be the opposite of whatever's in these brackets, right? Okay, so 14 sine 34, 23 cos 29. All right. And Fx is equal to negative 12.288 newtons. Okay, so let's find our Fy. I'm just doing math here. Okay, and Fy is, of course, going to be the opposite of whatever's in these brackets, right? So 14 cos 34 plus 23 sine 29, and that's negative 22.757. All right, so let's draw a picture of this guy. I always draw x first and then y. So I'm going to go to the left. I'm going to go down more than that, right? So here's our negative 12.288. Here's my negative 22.757. The vector, you try to draw a straight line. All right, we're going to find that angle and then this magnitude, right? So that angle there is going to be tan minus 1. This is just vectors over again, isn't it? And then I'm going to go 22.757 over 12.288. All right, so second tan of that guy, boop, divided by this guy, boop. Now, I fully expect a number bigger than 45 degrees, right? Okay, so 61.6 degrees. 61.6 degrees. And then the magnitude of that's going to be the square root of 12.288 plus 22.757 squared. All right. Okay, but I've got a TI calculator, so this poses a challenge. Square root of, okay, I've got this. Parentheses, I'm going to go up and grab that number. With a TI calculator, be very careful of the minus signs. In your calculator, these have minus signs. When you bring them down and square them, the TI calculator will make the result of the square of a negative number. So just be careful. Betrayed by your calculator. Okay, I think I've got this. It should be bigger than 22.757, right? And I'm getting a magnitude of 25.9 roughly. 9 newtons. Okay, so this is your answer. You need to draw me a resulting vector. It needs to be an arrow. You need to show which angle you're finding. 61, that angle right there with the x-axis is 61.6 degrees. This magnitude's 25.9. There it is. That's how you do it. So you just break it down, break them into components, and then throw whatever this is, set it all equal to 0, and solve for what those components have to be to make it 0. Yeah.